Alright, so this question is count completely tree node. So you given a tree node, basically you want to count how many nodes in the tree. So in this question you can do a lot of different way, but here's a first solution is using a DFS. So you're going to check yourself if your tree node is equal to no. If not, you go left, and then if not no, you just keep going left, and then you will just add a result based on left and right. So it's pretty much like in order, to be honest, in order traversal, but we twist a little bit. So let's start coding. So let's look at it. So if tree node, which is root, equal to no, you want to return 0, and you can say left equal to count node root.left, and then right equal to root.right. So this is your left branch and right branch, right? But you want to also include yourself when you return. So this is a pretty straightforward solution. Submit. Alright, so in this solution is actually time is actually all of them. Space is what? Constant. So let's work on this a little bit, just using the same method, using DFS. So if root does not equal to no, does not equal to no, I'm going to say 1 plus what I type, say count root.left plus root.right, and else it's going to be 0. So this is the if else condition, so you don't have more lines to compile. So if you want to make sure this is equal, then else 0. If root equal to no, then it's 0. Else it's going to be 1 plus this guy. So they are the same solution. So let's look at this. Yeah, time and space should be the same. Alright, so let's back to the another solution. So in this solution is what? I'm going to traverse from here. I'm going to traverse all the way to the left and check the depth, the deep of the tree, right? The height of the tree, and then I'm going to traverse all the way to the right. So in this case, it's going to be here, and I'm going to compare the height for here and here. If they are the same, I can actually just use the use the method. So it's going to be 2 to the power of what? H minus 1, right? So this is the height of the tree. So imagine this is what? Imagine there's a node. So 1, 2, 3, 4, 5, 6, 7, right? So the height of the tree is 3. So 2 to the power of 3 minus 1 equal to what? 2 to the power of 3 is 8. 8 minus 1 is 7. So this is the math behind it. So if this is a completed tree, right? If the height are the same, I can do this. So if not, I'm going to break this tree to smaller tree. So since this is not a completed tree, right? Oh, I need to erase this. So I will say, okay, I'm going to say 1 plus, and then this guy. This will be a tree. This will be a tree itself, and I'm going to calculate the tree on its own, and I will return back quickly. So this is a little bit better efficiency for sure. All right. So sorry. So here, so if root equal to no, I'm going to return 0, and I'm going to say in left. I'm just going to say go left, and then put a root in here, and then right, go right, root, right? So if left and right are equal, I can just return right away, right? 2 to the power of left, which is going to be what? 2 to the power of h, right? And minus 1, right? If not, I'm going to say 1 plus tree node, count node, root.left plus root.right. So it's straightforward enough. And what we need to do is we need to do this guy, right? So public int go left tree node. I'm going to just say no. So in this solution, I'm going to say in result equal to 0, and I will return result, and then I will say, well, no, it's not equal to no. Should be no.left. It's not equal to no. So this has to be the valid node before we move forward, right? So that will count as a completed tree, right? And then I'm going to say, okay, no equal to no dot left, and then I'll increment my counter. So again, easy, copy and paste if you don't make mistake, and you say go right. Alright, so this is the insert. So time and space. So the average for this one is going to be shorter than the last one, the DFS one. So I would say log n for time. Space is going to be constant anyway. So this will be it. Alright, so next one, if you have DFS, most likely you have BFS, right? So BFS is pretty straightforward, one at a time and then adding. Alright. This is just too simple. I'm just just stop coding. I don't care. So q equal to tree no, and then I'm just gonna say q equal to new linked list. So I initialize q. I'm just add the tree no, which is root, into the queue. Make sure I have a counter. I'm gonna return the counter, which is result, and I'm just make sure the queue is not empty. Alright, I need to make sure I have a size, the current size for this level, right? And then I'm going to traverse the current size, and then for each size, for each iteration for for loop, I'm going to poll, and then for each node, I'm going to just increment. This is counted as what? A single valid node, right? And I'm going to check for what? The node.left. If node.left is not null, I'm going to add into the queue. And then if node.right is not equal to null, which is valid, queue equal to offer dot node.right. So this will be it. And then after this, yeah, this will be it. Oh, tree no, come on. So yeah, this is a little bit more readable for new beginner. And the time and space, time is definitely elephant, space is going to be elephant, because you are going to store every single node into the queue, and this will be the final solution I have. So if you have a question, leave a comment, and I'll see you next time. Bye.